In this video, I'm going to solve this second order non-homogeneous differential equation using the variation of parameters. So this is my differential equation, this one, and I'm going to use the variation of parameters. So variation of parameters, it actually exploits two things. One is the homogeneous solution to this equation, this one, as well as the Wronskian along with the coefficient of the y double prime. That helps us get the particular solution, then we combine it with the homogeneous solution to get the general solution. So let's go ahead and solve the problem. So you have y double prime plus 2y prime plus y is equal to 0. If we assume our solution is going to be of the format e to the power rt, then you take the derivative of it is going to be e to the power rt and r square e to the power rt. And if I plug in these values here, I'm going to get r square plus 2r plus 1 times e to the power rt, which is equal to 0. Obviously, e to the power rt is not equal to 0 because it's an exponential function. So that leads me to the next one, r square plus 2r is equal to 0. 2r plus 1 equal to 0. So r square plus 2r plus 1 is equal to 0. That factors to r plus 1 times r plus 1. So that tells me that r is a repeated root of negative 1. So my y1 is going to be e to the power negative t. And then obviously you know your y2 is going to be t times e to the power negative t. Now we are going to use this y1 and y2 values to find the Wronskian. And the Wronskian is going to be this. Is going to be determinant of y1 prime, y2 prime. So that's going to give me determinant of y1 is e to the power negative t and y1 prime is going to be negative e to the power negative t. y2 is going to be t e to the power negative t and y2 prime is going to be e to the power negative t minus t times e to the power negative t. I just used the product rule here. And the determinant is going to be e to the power negative 2t minus t times e to the power negative 2t plus t times e to the power negative 2t. And that gives me Wronskian is equal to e to the power negative 2t. Now we are going to use the variation of parameters formula. Here I just use the formula. I don't show you how to derive the formula. So we'll just go ahead and plug in the values in the formula. So the particular solution is going to be y sub p of t. That's going to be equal to negative y1 times integral y2 g of t over a of t times the Wronskian w integrated with respect to t plus y2 times integral y1 times g of t divided by a of t times w, all of it integrated with respect to t. Now, where does these symbols come? Where do these symbols come from? Okay, I just wrote a formula, and you see a bunch of symbols, functions and solutions. Where do they come from? It actually comes from the second order differential equation, the homogeneous general version of the second order differential equation, which is this, by the way, a of t times y double prime plus b of t times y prime plus c of t times y is equal to g of t. That's the general format or structure for the second order linear homogeneous, non-homogeneous or differential equations, okay? And if g of t is 0, then it's homogeneous, of course. Now, a of t is the coefficient of y double prime, as you can see right here and here. W is the Wronskian, which we already found here. And then y1 is the solution we found here, and y2 is the solution, the corresponding homogeneous equation we found there. Now we have everything that we need in order to find the particular solution. So let's go ahead and find the particular solution. It's just a bunch of algebra. So y sub p of t is going to be equal to negative e to the power negative t, because y1 is e to the power negative t, integral t times e to the power negative t, that's the y2, and g of t, remember in our problem g of t is e to the power negative t over t square, times 1 over a of t. A of t is just 1 because coefficient of y square is 1, times Wronskian, which we found to be e to the power negative 2t, all of it integrated with respect to t, and plus t times e to the power negative t integral y1 e to the power negative t, right, times g of t, which is e to the power negative t over t square, times 1 over 1 times 1 is the coefficient of y double prime, times w e to the power negative 2t integrated with respect to t. So y sub p of t is going to be equal to e to the power negative t, negative right here, and some things are going to cancel out. These are going to cancel out. T goes into t square, just t times. So that gives you integral dt over t, I think. So it comes down to something simple. Plus t times e to the power negative t, so that's the second term, this guy, integral again e to the power negative 2t, and these two are going to cancel out. That's going to give you dt over t square. Now if you integrate those, you're going to get the following. Is going to be negative e to the power negative t, integral of 1 over t dt is nothing but ln of t, so let me put it inside absolute value, plus t times e to the power negative t, and integral of 1 over t squared dt is going to be negative 1 over t. All right, so that's going to give me y sub p of t to be negative e to the power negative t ln of t absolute value, and then this t and this t are going to cancel out. That's going to give me negative e to the power negative t. If I simplify it, it's going to be negative e to the power negative t times 1 plus ln of absolute value of t. So your y sub p of t that we found using the variation of parameters is going to be negative e to the power negative t times 1 plus ln of absolute value of t. Now I'm going to take this particular solution, combine it with the general solution for homogeneous part, which is going to be, so my general solution is going to be y of t is equal to y sub h of t plus y sub p of t. Y sub h of t is the homogeneous solution, general solution for the homogeneous equation, or the corresponding homogeneous equation, and y sub p is the particular solution that we got by using the variation of parameters. So y sub h is going to be c1, some constant or arbitrary constant, times e to the power negative t, plus c2 times t times e to the power negative t. That's just the homogeneous part, okay, this one. Then plus the non-homogeneous or the particular solution, which we found right here, negative e to the power negative t times 1 plus ln of absolute value of t. Okay, so the general solution is going to be y of t is equal to c1 e to the power negative t plus c2 t times e to the power negative t minus e to the power negative t times 1 plus ln of absolute value of t. Okay, so that should be your final solution, general solution to this differential equation. There is a lot of calculation, so as you follow it along, just keep an eye. It is possible that somewhere I missed a sign or something and ended up propagating it or whatnot. In case if I do, just make the correction accordingly or adjustments accordingly. So this is the process that you would follow to use variation of parameters to find the particular solution for non-homogeneous differential equation and then combine it with the homogeneous differential equation solution, corresponding homogeneous solution, to find the general solution, which we did here. I hope that this discussion was helpful. Thank you very much.